Do you know what word will be 187th out of all the words you'll say out loud tomorrow? Probably not. You can certainly not predict every word that you'll say tomorrow. Or can you? Defining random can be difficult. When we say that's random in everyday life, we usually mean that we didn't expect something to happen. Like when someone suddenly says something that's completely out of context in a conversation. What we'll call truly random in this video is something that is unpredictable and contains no recognizable patterns. But know that there is still a lot of debate about what's really random and what not. If we roll a die, the outcome is unpredictable if the external factors, like initial velocity, wind, air density, etc. are unknown to us. That is, if we are not able to measure them, and if we also can't control them. But that doesn't mean that the outcome is impossible to predict. Physics describes a lot of fundamental events happening in the universe, like gravity and friction. We can closely predict what will happen in a lot of situations when we know the initial conditions. How about coins and dice? They are also influenced a lot by imperfections in the object itself. Because of that, it's better to catch the coin in your hand when doing a coin flip, so it does not fall over to its heavier side when spinning. Maybe you're thinking right now, we can't predict the future, that's impossible. There is indeed still a lot that we can't predict, but take the weather forecast for example. It's not accurate all of the time, but that's mainly to do with not knowing the exact initial conditions and the fact that it's a chaotic system. If one of the initial conditions that we measured is a little bit off, the further we go in the future, the more effect it has on the weather. This is known as a butterfly effect. The name derives from a metaphorical example of a tornado being influenced by minor perturbations like the flapping of the wings of a butterfly several weeks earlier. If all our measurements would be 100% right, would we be able to predict what will happen in 100 years? Some things, yes. We for instance predicted that the heat death of the universe will be in a Google years. That's way more than 100 years in advance, and our measurements are never completely accurate. Still, chaotic systems like the weather are not completely predictable, even when we would have exact measurements. From the moment a small thing changes, the butterfly effect implies and it can have some big impact. In general, even having fully accurate measurements makes for unpredictability, due to some very big and very small things. The universe keeps expanding and there is only a certain region that we can observe. The observable universe is about 9.3016 light years in diameter. That's about this many kilometers, or almost 3 quadrillion times from the Earth to the Sun and back, so it's understandable that we'll likely never be able to know the conditions from outside the observable universe, or at least not in the near future. If particles from outside the observable universe can influence what we observe, we're not sure. We also don't know if the same rules and dimensions imply outside it. On a ridiculously small scale, nature becomes fundamentally random. Quantum mechanics describes the physical properties of nature on an atomic and subatomic scale. There are big differences between classical mechanics and quantum mechanics, from observing particles to the behavior of them. It is so complicated that I think to explain this you should study quantum mechanics, and I can't explain it completely. It seems that when we don't look or observe, particles can exist in a superposition of possibilities, and generally do not have deterministic properties like position, velocity, or energy. But when we look, something changes. This is also known as a measurement problem. It seems like some things are determined by a deep-seated randomness woven in the universe itself. Because of this, some things might be truly random. You can, however, calculate probability distributions for the position of particles, momentum, etc. using differential equations. Let's forget quantum mechanics for a second. There are 12 particles of matter which interact in 4 predictable ways. Does that mean that everything is predetermined? And if so, do we have free will? You would think it is, but because quantum mechanics tells us there might be some unpredictable things, we don't know. There is still a lot of discussion around topics like that. There is one last thing I would like to talk about: pseudorandomness. This is the extent to which a sequence of numbers appears to be patternless while generated by a deterministic process, like in software. When you use a random number generator and generate a number, the outcome will probably not be truly random. The reason for this is that a computer can only understand determined instructions. It cannot generate something random. A random number generator is always based on a piece of data, like a secret pre-generated sequence or physical measurement, like the operating system's time. Most pseudorandom number generators are based on time and with some kind of algorithm generate a seed, which is a number or vector, from that. With that, it uses another algorithm to get consecutive random numbers. Because of this, pseudorandom is not truly random. Even when we ourselves try to think of a random number or card from a deck of cards, it's not truly random and heavily influenced by other factors like our environment. Magicians and mind readers often use this to their advantage. You can, however, generate something almost truly random using a computer that has hardware made for that purpose. Such devices are often based on microscopic phenomena that generate low-level statistically random noise. Physics can make for quite random, but sometimes also predictable phenomena. We learn about atoms and molecules, planets and star systems to map what we can and cannot know. If you want me to make a video about randomness from the perspective of mathematical probability theory, let me know in the comments. Also, don't forget to leave a like if you enjoyed the video and subscribe for more content. I hope I'll see you in the next one. Bye!